Okay, so we're going to look at logs or logarithms, or whatever you want to call them. So a log is a particular type of function. Again, it's related to our exponential functions, which is what we've seen. So it's related to what we would call the index or the exponent of a number, and generally we would call that the power of the number. So a log is related to the power or an expression of the power of a particular number. So that's how we kind of talk about them being related to our exponentials. So for example, if we have 3 squared is equal to 9, or 3 to the power of 2 is equal to 9, we could rewrite that as log to the base 3. So this number down here, let me actually keep my colours consistent, log to the base 3 of 9 is equal to 2. And it's important for us just, I suppose, to get that sense of what do these different numbers mean and where they are. So this number down here, the smaller number, is our base number. And in terms of our exponentials, that is related to this number up here, this base number here. So your base number was the number that we wrote in kind of the normal sized. And the next number, the 9, was maybe what we considered to be our answer with these exponentials. So the 9. And then our power, which is the 2, is now our answer to our log questions. So we kind of have to keep this in our head that a log or a logarithm is a power. Okay, when we find the log of something, the answer is a power. So it's the power that we need to raise 3 to in order to get 9. Or if we kind of say that a bit more simply, 3 to the power of something is 9, and our answer is 2. So when we get log base 3 of 9, we are looking for, okay, what's the number that I have to do 3 to the power of in order to get 9? And the answer then is 2. So we can apply the same idea, I suppose, to 4 to the power of 3. So again, our base is going to be 4 this time, because that's the number here. So that's our base number. So we're log of base 4 of 64, 64 here being our answer, I suppose, to our exponential one. And we're essentially asking ourselves, 4 to the power of what is 64? And we should know then that the answer is 3. And what this is going to do is it's going to help us with these questions so that we don't have to spend time using our calculator trying out different powers until we get the one that we want. With our log and using our calculator, we're going to be able to find those out much, much quicker. And that's the goal here. Same thing we can apply then with these colours as well. To 5 squared is equal to 25 gives me log to the base 5 of 25 is equal to 2. Okay, and then again with this next one, 2 to the power of minus 1 is equal to a half. That was one of our exponential rules. Anything to the power of a negative number becomes 1 over that original equation. So 2 to the power of minus 1 becomes 1 over 2 to the power of 1. So that is going to be log to the base 2 of a half is equal to minus 1. So we're seeing here that the answer to a log question can be negative. The value that we get, the value of the log, can be negative. We're going to see later that there are certain parts of our log questions, of our log kind of formula or rule, that can't be negative, that we can't have. But the answer, the actual overall value, that can be a negative number because we can have negative powers. So just a more formal definition here, the log of a number is the power to which the base number must be raised to get that number. Okay, so in terms of the log of here, the log of y is the number for which we have to do a to the power of in order to get y. Okay, it seems a lot more confusing when we're using all these letters, but just bear in mind these examples we have here, keeping your base number as the one that we think of as being 2 to the power of something or 3 to the power of. It's the one that is to the power of. Our power is our answer, our overall answer. So our log, the answer to any of these log questions is going to be a power. And then the number in the middle, that y there, is your answer to your exponential ones. So that's what do I get when I put the base number to that power. Okay, so it's a handy way to move between our exponentials and our logs. So as we said here, and this is just again following on from what we had earlier, if log to the base 2 of 32 is equal to 5, what that means is that 2 to the power of 5 is equal to 32. Okay, following on, just keeping in mind what this means for us. How can we rephrase this, and can we say it in a way that we are going to remember exactly what it means so that we can translate easily between our exponentials and our logs? That's the goal. So looking at this first example, we have log to the base 9 of 27. Okay, so let's have a look at this one. Let's rewrite it out. So log to the base 9 of 27, and we have to just think about what it means. So the question is saying 9 to the power of something is equal to 27. 9 to the power of something is equal to 27. Generally in maths, if we have something and we don't know what the something is, we just give it a name of x. So if we're rewriting this as an exponential, we're saying 9 to the power of x is equal to 27. So we haven't actually changed the question there, we're just rewriting it. Instead of log form, we are rewriting it now in exponential form. So we can make a note here that this is maybe exponential form. Okay, so this is what we're more used to saying in the previous sections. So now I have 9 to the power of something is equal to 27, and using our knowledge of our exponentials, we can rewrite that as 3 to the power of 2 to the power of x is equal to 27, and that's 3 to the power of 3. Okay, and I'm just rewriting things here into a base that I can work with. That becomes 3 to the power of 2x is equal to 3 to the power of 3, which means I have 2x is equal to 3 and x is equal to 3 over 2. Okay, so that means that the answer to log to the base 9 of 27 is 3 over 2. Okay, so let's just highlight that answer for us here. Just making sure that we can see where everything's happening there. So at this point here, I'm just setting the exponent so the power is equal to each other. Again, these are things that we've seen in the previous section. So the key part there is this change from exponential form, from log form to exponential form. Once we've got to exponential form, we should be able to finish the question out from there. Let's apply the same idea to the next one. So log to the base a third is equal to 9. Or log to the base a third of 9, sorry. Again, we'll say it's equal to x. We're saying a third to the power of x is equal to 9. That's what it means. That's how we would say it in our head. If it's to the base a third, we're saying 1/3 to the power of something is equal to 9. We can rewrite that as 3 to the power of -1, all to the power of x. We should know if we have a question like that, as we had in the previous part, if we have something to the power of one thing and then it's all to the power of another thing, we can multiply those two powers. So that becomes 3 to the power of -x. That's all equal to 3 to the power of 2, because 9 is 3 to the power of 2. We can then take the two powers and set them equal to each other. So -x becomes equal to 2, which means of course that x is equal to -2. And that's our overall answer here for that equation. And lastly, let's look at one more, just to really make sure that we're getting the hang of these. Again, setting it equal to x, because we don't know what that value is. We don't know what the end result is. So we have √2 to the power of x is equal to 8. We should remember that the square root is the same as the power of a half. Okay, so then again multiplying, we get x over 2 is equal to 8 is 2 to the power of 3. And again, we're doing a lot of switching here, but this is something we should be familiar with from our exponential questions at this point. Then we take the powers, we set them equal to each other. X over 2 is equal to 3, which means that x is equal to 6. And that's our overall answer for this question. So the key thing with these questions is being able to make that change between between log form and exponential form. And what we're going to see as well is making the change the other way is going to be important as well, from exponential form to log form. If we have questions where we have a power and we want to work out what that power is, we might need to use our log form in order to work that out. So moving forward, we're going to look now at the laws of logarithms. Okay, so similar to our laws of indices, we have quite a few rules that we can use to help us with these log questions. And remembering that a log is a power. Okay, that's key to these, because a lot of these rules are similar to your exponential rules, and of course there's a relationship between those. If we use our logs, we can rewrite some of these exponential rules and see where those connections are. So I've taken this page from your formula and tables book, because that's what we need to get used to seeing, and that's how we need to get used to seeing them written. There's a few things we should note as an overall rule, and the main one being that for all of these rules, the bases are the same. This base number a, I'm not even going to highlight them all, but I've highlighted the first few there. And we can see that if we have, for example, log to the base a of x multiplied by y, we can rewrite that as log to the base a of x plus log to the base a of y. We can split it up into an addition. But we see there that the bases will be the same on the right hand side for both terms, and the same as the base that we had on the left hand side. Okay, so the bases aren't changing there from one step to another. What it also means is that if we have a question like on the right hand side here, where we have two terms, two log terms, in order to use this rule, we must have the same base on both of them. And that rule really applies to all of the rules that we have here. The bases must be the same. So let's just make a note for ourselves just at the top here. So NB, bases must be the same. To use these rules. Okay, so the bases must be the same to use these rules. If our bases are not the same, we can't use these rules to move from one form to another. Okay, so that's going to be really important. So we're going to go through them one by one just to see how they work, to see how they interact. So let's start with the adding rule that we were talking about there. So what this means, if we nearly focus on the right hand side, and we'll work our way to the left, but what it means is if we have two terms, so log to the base a of one thing and log to the base a of another thing, if we have two different terms with the same base, we can rewrite that as log to the base a, same base again, but we can multiply the two kind of subject terms there, the x and the y. So we can multiply those two terms by each other. So let's see that in action. If we have a question here like this one, log to the base 2 of 8 plus log to the base 2 of 4, we can rewrite that as log to the base 2, keeping the base the same, and we can multiply the two other terms, the two subject terms if you like. 8 by 4, log to the base 2 of 32. Okay, so we can maybe have a look at that one. So log to the base 2 of 8, so 2 to the power of what is 8, that's 3. 2 to the power of what is 4, that's 2. And 2 to the power of what is 32? Well, that's going to be 2 to the power of 5. So 3 plus 2 is equal to 5. So we can see that the rule does hold for this question and for all questions that we would look at. But it's a quicker way of us maybe simplifying these equations. Instead of having two terms, we can have one term. Subtracting follows a similar idea, and we'll see the rule up here. If we're subtracting two logs, we can rewrite them with those subject parts, those x and y's, as a division instead of now a subtraction of the two terms overall. And making sure that when we do this, that we don't accidentally write the whole thing as a fraction. So we can see here it's not that all of it becomes a fraction, it's that this 27 and this 9 are divided in the middle here, those kind of subject parts there. So 27 over 9, of course, is 3. If we look at this one, 3 to the power of what is 27, so that's going to be 3 to the power of 3 minus 3 to the power of 2, which of course is 1. Log to the base 3 of 3. 3 to the power of what is 3, and that again is 1. And 1 is equal to 1. So we can see that it does hold again. Looking at the next example that we have, and it's to do with a question where this middle term, this subject term, is also raised to a power. So here we have log to the base 2 of 8 to the power of 2. And what our rule tells us here is that if we have a question like this, where we have that middle term, that subject term has a power, we can take that power down to the front. And it becomes log 2 log to the base 2 of 8. Okay, it becomes 2 log to the base 2 of 8. Okay, it's related to our exponential rules. We don't have to get too deeply into it though, because it's something that will be written for us. But that's this third rule here. So that's the one with the q there that we can see, where the q then becomes a multiply at the front of the term. Again, can be a very, very handy rule, and it's one that comes up in a lot of questions. It's a very, very common translation or transformation that we have to make. The next example is to do with ones and zeros. Okay, so let's think about this one. Log to the base 4 of 1. Okay, what does that mean? That means 4 to the power of something is equal to 1. And we should remember from our exponentials that anything to the power of 0 is equal to 1. So if we have a question where that subject term or that subject part in the middle is 1 and our log is anything at all, the answer will be 0. The only way that anything to the power of whatever can be equal to 1 is if that power is 0. The next term then we end up with is to do with if we have a question like 1 over something. Okay, log to the base 3 of 1 over 9. And to kind of look at this rule, we need to rewrite the 1 over 9. So we can rewrite it as 9 to the power of minus 1. When we see this, we should be thinking of one of our earlier rules that we saw that we were introduced to. It's this rule number 3 here. So instead of this, we can rewrite it as minus log to the base 3 of 9, or minus 1 log to the base 3 of 9. And if we know then log to the base 3 of 9, 3 to the power of what is 9? That's 2, so it becomes minus 2. Yes, that's rule number 5. Rule number 6 is an interesting one as well, and this is one that isn't as explicitly written in these rules here. It's related to this rule over here as to how this ends up just being x with no log term, but it's not as explicit. So let's have a look at it. Log to the base a of a, or log to the base 2 of 2 is what? So essentially what we're saying is 2 to the power of what is equal to 2. And of course that should be fairly clear that the only way that could be is if the power is 1. So we get 2 to the power of 1 is 1. So if we have a question where the base and that subject bit in the middle are the same number, then the answer is going to be 1. Okay, remember again that all these log questions result in a power. Looking then at change of base, which is the last rule, that is our rule over here on the right hand side, it's this rule here. If we want to change the base of a question, and this can happen, sometimes the base that we have is not the base that would be the most useful for us. So maybe in the question every other term has a different base and we want to simplify it. And what we need to do to change our base is instead of it being base B, we can see now that it becomes base A. That's the base that we want to change it to. And both the term on the top and bottom of the fraction have this new base, this base A. The subject term becomes the top one. So on the top, we essentially just rewrite the question, but with the base that we want. Instead of B, it becomes A. On the bottom, we see then that we rewrite again with our new base, but that subject term is going to be the old base that we had. So to change the base, the top of our fraction is the question that we'd want. So we've changed the term with our new base. On the bottom, we're still using the new base, but in that subject place, we now have what was our old base. And again, if you follow the letters and if you keep things consistent, you shouldn't have any issue copying this down from your formula there. So it's not one that we need to know off 100%, but we can get familiar with using it. So we can see how this one looks with this question here, say log to the base 2 of 9. Now 2 to the power of something equal to 9 doesn't really work all that well for us, but what we can try is maybe change it to another base. So say change it to base 3. So now it becomes log to the base 3 of 9. But from our rule, on the bottom of my fraction, I would have to say log to the base 3 of 2, which was my original base. And we know then that log to the base 3 of 9, 3 to the power of what is 9? That's 2. So we can actually end up with a question like that there, where it simplifies down a little bit more. And that might help us out in certain situations. We might have situations where we're able then to kind of simplify or have common factors or things like that, where maybe that last term or the bottom term can kind of be eliminated. So we're going to look quickly at an example here of finding the value of log to the base 8 of 16. Okay, so let's have a look at this one, log to the base 8 of 16. So this one isn't going to be an awful lot different from the ones that we've seen already. So we have 8 to the power of what is 16, and 8 to the power of what is 16. Okay, so we can't figure that one out. Okay, we don't actually know, so we could try 2. 2 to the power of what is 8? 2 to the power of 3. 2 to the power of what is 16? That's 2 to the power of 4. And again, we're really just doing this in the same way that we've done the last few. So not really using our rules too much here. So perhaps not the best place to put that example, but just keeping ourselves fresh. Okay, let's look at one example then that actually uses the rules. So say this one here. So we're told without using a calculator, simplify the following number. Okay, 2 log to the base 10 of 3 plus log to the base 10 of 16 minus 2 log to the base 10 of 6 over 5. Okay, so we have a fair bit to do here. First of all the bases are the same. That's good for us. That means that we want to start using our rules, that we're able to do so without really any real issues. We're not going to have to change bases or anything like that. So what I would do first is maybe focus on the numbers in front, because we can't do a whole lot without sorting those out first. Okay, we can't do an awful lot without kind of dealing with those. So let's have a look at those. So we're looking first of all at this term here, the 2 log to the base 10 of 3. And I'm going to rewrite that using our rules as log to the base 10 of 3 squared. Okay, we know that that's kind of working backwards from this new rule that we've met. We can keep the next one the same. We don't have to do anything with that one. And we'll do the same thing here, log to the base 10 of 6 over 5 squared. Okay, on the next line, let's just tidy those up a little bit. So it becomes log to the base 10 of 9 plus log to the base 10 of 16 minus log to the base 10 of 36 over 25. Okay, so there's a few things we can do here at this point. What we might decide to do is to work with this left-hand side here. So where we see this addition. So that would seem like a good place to start for us. So let's have a go at that. We should remember that when we're adding two log terms, what we can do is we can multiply those subject terms at the end there, those terms in the brackets. We can multiply the two of those to make our equation a little simpler. So we're going to have 9 multiplied by 16, and 9 multiplied by 16 is 144. So we have log to the base 10 of 144 minus log to the base 10 of 36 over 25. Now, as for what we can do at this point, we need to remember that if we have a minus in the middle of two log terms, that we can rewrite that as a division. So it becomes log to the base 10 of 144 divided by 36 over 25. Okay, and we can rewrite that then. So let's have a look. Let me see, 36 over 25, and that becomes log to the base 10 of 100. And without any real issue, we should be able to see that log to the base 10 of 100 is 10 to the power of what is equal to 100, and that's going to be equal to 2. So we've simplified down our whole answer there to just 2. Now we might ask, why did we have to look at this at the start? Why did we have to start with this step of eliminating those 2's at the front, these 2's here? Why did we have to start with that step? And the reason's fairly simple. If we look back at how these rules were written for us at the very start, we can see that nowhere in these rules are we adding or subtracting terms that have a number at the front of them. So generally, to use these rules, the best thing we can do is simplify the terms. If we have a power like that we've written down in the front and multiplied at the front, the best thing to do would be to bring that back into the equation. Because we can see up here, where we have these additions, that at the front we have no numbers. It just makes it easier for us to work with. Okay, it just makes it generally easier for us to consider. Okay, otherwise, fairly straightforward, following through, just keeping everything consistent. Okay, is the main thing, just as best we can, following everything along. We can look maybe at one of the examples using the change of base rule. So very quickly, just trying to change base from here. So instead of writing it as log to the base 2, we might decide to write it as log to the base 3. So log to the base 3 of 128. If we remember our rule on the bottom, it becomes log to the base 3 of 2, which was our original base. This is log to the base 3 of 45 minus log to the base 3 of 5. Then we might decide on the right hand side here to simplify this question. Okay, so that becomes log to the base 3 of 45 over 5, and continuing along, and we get log to the base 3 of 9. Okay, and we could simplify that down a little bit more. Log to the base 3 of 9, of course, is 2. In terms of this left-hand side, There's a good point to introduce. And it tells us to simplify the question without using our calculator. But this is a good point to just introduce the use of the calculator. And on our calculator, we'll see a button and it's called log. And we may see one that just says log like this. Okay, let me see, I'll write this down below here. Okay, so we see a button that just says log. Okay, this is what we would call log to the base 10, and it's an example of a common log that we use. Okay, and this is one that we'll use quite a lot. So if you use that button on your calculator that just says log, that's going to be log to the base 10. If instead you use the button that looks like this one, where it has two boxes afterwards, that will allow you then to input the base number and that subject number at the end. So for example, we could put into our calculator log to the base 3 of 128, and we could see what answer it gives us. So log to the base 3, because we wouldn't be able to work that out very quickly for ourselves. And as will happen with a lot of these questions, we get a decimal number, okay, not a clean cut number. So this is the other aspect of logs that can be really, really useful. So in terms of working out powers of numbers when the numbers don't work out nicely, when we don't have a clear power of 3 that we can just work out by estimation or by rewriting as 3 to the power of x is equal to something, then we're able to use our log button on our calculator to work out these sums for us. So same thing with log to the base 3 of 2. If we put that into our calculator using our new log button, log to the base 3 of 2, and again we get a nice decimal number, 6309, roundabout, so rounded to a few decimal places there. So using this log button on our calculator can be very handy, and what will happen is that with most of the questions we'll be doing, we'll be looking at log equations and looking at where we have values of x that we have to solve for. So we won't obviously be able to put those into our calculator, but using the calculator can be handy when we have questions like this, where we are able to just input them fairly simply, where we have number terms that we can input and that we can work out. So as we've said there, if we have that button log, that is log to the base 10, which is quite a common base for us to use. We can also input any base that we like. Another common base is log to the base e. Okay, if we remember from our exponentials, e is a very particular type of exponential, e to the power of x. E is an irrational number. And log to the base e on your calculator would probably be like this, ln. Okay, and ln is log to the base e. So those two buttons, ln and then the simple log on its own, they kind of dictate what base you're going to use if you use those buttons. Whereas with some of these other questions where we already have a base as part of them, we might have to input the base for ourselves. But we're going to see in the next section where it's useful to use this log to the base 10 or this ln. Okay, there's particular situations where it works out being most useful just to use those common logarithms, those common bases.